Hello, everyone. There are 12 more minutes before the main event starts. Meanwhile, we can introduce ourselves, whoever has, arrived in the webinar. I can see at least 10 participants, 12, it's rising. It's good. So let's introduce ourselves. Uh, my dear audience members, don't feel shy. Feel free to introduce yourself in the Red Labs Discord channel. Thank you. It's a pleasure to, co-host this webinar with my colleague Prajwal. Anyone else would like to introduce themselves?
Yeah. Hello, everyone. Thank you for joining. I hope I'm audible.
Yes, Prajwal, you are completely audible.
Yeah.
I request everyone to please maintain the chat in the Discord itself. We won't be able to monitor the Zoom chat. It's a kind request to everyone. In case if you don't have the Discord invite, let me just share that in the Zoom chat so that I have shared the invite in the Zoom chat so that everyone can assemble at one single place. Anyone else would like to introduce themselves? Yeah, you can message in Discord. Feel free to put your queries or introduce yourself in the Discord chat. Red Labs channel, hashtag Red Labs. Yeah, you got it. Meanwhile, people introduce. So, Prajwal, if you want to share, like in one or two line,
Yeah.
like how is your experience while working in Altered?
Okay. So yeah, I think I have like initially I was a student, right? So I enrolled for CRTP and I like got it through a giveaway, and that's how my red teaming journey began. And the like from being a student to working for the same organization, I think it's a dream for a lot of people. And getting to work with people who actually design those certificate and deliver those services to us, I think it's been great. And when I actually started like working, now I realize the hard work that we put in. And I think to summarize it in one sentence, like for everyone listening, I would say if it's not the best quality, we don't let it go. We don't let it go to the public. Yeah.
Thank you. It was wonderful hearing your experience while working with us. I guess somebody's typing. We have 5 more minutes. If somebody wishes to introduce themselves, they can introduce in the Discord channel. The channel name is Red Labs. In case if you do not have access to Discord, you can quickly join it. I have shared the link in the Zoom chat. I guess multiple people are typing. Do you have any volunteer positions? Uh, I am not sure about your question, like volunteering in exactly what? Okay. I guess you can mail us and the concerned department will look at it. I, as a researcher, don't have, you can say, access to that sort of information about the positions. Yeah, like you can mail us, like the email IDs are already mentioned in the FAQs. So let me just share my screen.
Yeah, the Discord link is already in the Zoom chat.
Someone is a pre-final year student in Chennai, from Chennai. Great to have you. Anyone else would like to introduce themselves? We have 1 more minute before we formally begin. Someone is typing. There are a lot of Akshay's and I'm not sure exactly which. like who exactly you are, but I'm pretty sure like after this webinar, we could have a one-to-one chat on Discord so that you can remind me. Anyways, like just let me know on Discord if my screen is visible. Great. So let's begin. So hello everyone. A very warm welcome to the third webinar of Altered Securities month of Azure Red Teaming 2026. Our topic for today is zero permissions, full impact, abusing Azure's global ARM APIs. It's been a real pleasure in co-hosting this webinar with my colleague Prajwal.
Hello, everyone.
Before I go ahead, I would like to just give us an introduction about us. Those of you who are new and meeting us for the first time in this webinar, let me tell you that we are basically an edtech startup which has a focus on enterprise security learning. We have trained more than 50K security professionals around the globe, and we have a laser sharp focus on Microsoft technologies. We basically cover your on-prem red teaming and Azure. We have a lot of offerings, and we always try that our labs are, you can say, affordable, easy to access, and very much fun to solve. About me, as like I introduced in the start when before this, in the pre-introduction chatter, that my name is Hitesh Duseja. I also conducted the first webinar of this month, and uh, I'm basically a security researcher at here at Alter. I have a strong passion for enterprise cloud security and red teaming. Being part of this industry for more than 7.5 years, and I absolutely love my job. I have done an original research in Intune. It is now part of our Azure offerings. And I've also worked on hybrid identity, whose research, for obvious reasons, has not been yet made public. Now I will let my colleague Prajwal introduce himself. Prajwal, over to you.
Yeah, thank you, Des. Hello, everyone. My name is Prajwal Kumar Pandey, and I work as a security researcher at Alter Security. Talking about my career, it began directly with Azure, and like Azure was the platform that I had to understand deeply from the ground up, and I'm very passionate about it. So I have done a lot of certifications, as you guys can see in the slide itself. And so I spend a significant amount of time looking into how Azure and Intra ID behaves, but not just in theory, but in practice as well. Over to you, Vitesh.
Thank you, Prajwal. Before we get to the meaty stuff, I will just take a moment to explain about our mission, vision, and core values. To say in one line, or to keep it simple, our mission is that whatever we teach to our students in enterprise security, it should be highly accessible into their careers. That is the quality we strive for. And that is our one of our qualities apart from innovation, empathy, and giving back. Because we love to give back, this is the reason we are having today's session and the sessions we had in the past, as well as the session we are going to deliver in the next week. So, what is month of Azure Red Teaming? If I have to explain, in popular discourse, whenever red teaming is you can say, discussed among peers, it is usually limited to on-prem environments. There's a serious lack of awareness about Azure and Entra-ID threat landscape. Month of Azure Red Teaming is our way to bring a change by having meaningful discussions around Azure. With the webinars that we had in the past and today's webinar also, we want to emphasize that if you wish to learn Azure Red Teaming, you do not need to spend thousands of dollars. You can simply go to our Red Labs platform and learn about it. The demonstration of which will be covered in the next slides. Now, there are some ground rules which I want to set. For any questions, you can ask only on Discord. Zoom chat monitoring is not an option for us. Apart from that, we are going to demonstrate a lab today. There will be a full-blown scenario. That lab will be made available on upcoming Monday, which is 27th of April 2026. So there is no follow along. Just sit back, relax, and enjoy what we are going to teach today. To ensure a smooth experience, I request everyone in the webinar to keep their microphones off so that uh, Prajwal and I, whatever we speak, reaches to all the participants uniformly. Lastly, I request everyone to maintain a professional and respectable behavior throughout the webinar. Now, are there any queries before we get to the meaty stuff? Or is the ground rules understood to everyone?
It is in to allow me to share the screen.
Yeah. Over to you, Prajwal.
Yeah, thank you, Hitesh. Thank you for the lovely welcome. So let me just quickly share my screen. Okay, great. Okay, so uh, let's just start with the fundamentals, the foundation of the attack that we will be covering today, and that would be Azure App Service, right? Now, Azure App Service is a fully managed platform. I would request, please don't describe anything, don't use the automation. So, Azure App Service is a fully managed platform, which is a fully managed platform as a service offering from Azure. It allows developers to deploy and scale web applications without worrying about the underlying infrastructure. When I say fully managed, Azure takes care of few responsibilities like OS patching, server maintenance, load balancing, that kind of stuff. We only deal with the application code. Well, uh, with app service, we can create like customer portals, website, backend APIs, and other things like that. Now, when we talk about web applications, it's not a standalone thing in an enterprise. It's just a piece, it's just a piece of a large picture around it. There are multiple components that integrate together to make it fully functional. Like we have app service plan, that is the actual compute or the memory and the CPU. So these are the things that is taken care by the app service plan where we host our web applications, right? So we can either create a app service plan pre-hand or it will be deployed when you create your web app. There are multiple components that can be integrated with an web app. Like we can have a server, like you can have a backend database server, or you might have a storage account holding access like the assets, and we could be holding key vaults, the connection strings, and a lot of things. So there are a lot of integrating components to it. And one more thing is that the web app can be of two types. Either it could be a Linux based or it could be of Windows based. So depends totally on your choice. And So as we are talking about the integration, one core thing that comes into play when we talk about websites is the deployment part, right? So let's take a look at the deployment center. So deployment center basically enables us for continuous deployment when an web application. So for an web application from your source control, like it could be GitHub, Bitbucket, right? Whenever you have a code repository, it basically links your code to the web application itself. And every time a developer pushes a new code, this pipeline would pick it up, test it, and then deploy it automatically, right? So this pipeline needs certain credentials to talk with Azure, and it needs some kind of token to interact with GitHub, right? It would need some kind of access to do it. Now, if we see a website as a single thing, it might not look that complicated, right? But the ecosystem around it, if we talk about the deployment process, it's full of tokens, it's full of connections and integration. As you will see in the image, we are showing a deployment center where we have configure a GitHub integration with a particular repository and the branch is main. For the build, we are using GitHub Actions. So when you are actually making this configuration, right, you go to the deployment center for a particular web application and you authorize GitHub to do it for you. And what it does, it creates a GitHub action. So it creates a workflow in the repo that you have given it access for. And whenever you update the code, it would update the web application as well, right? So deployment center has other options as well. As you can see, there's option for containers, logs, and FTPS credential. If we talk about the logs part, it basically shows you the logs when you are making a deployment, right? Sometime you might have some issue where your deployment fails, or you might have an issue where your deployment is taking unusual amount of time, right? So you could look into this log and debug it. The other tab, which is the FTPS credential, that holds very critical pieces of information. So it basically holds two kind of credentials. One is application scope, and second is user scope. We'll be talking about it in the further slide in much more detail, right? So let's move forward. Okay, so now we understood the web application, the actual service that we will be exploiting. But let's take a step back and let's try to understand how Azure actually works. So under the hood, what is actually happening there, right? Uh, Everything in Azure is controlled through the Azure Resource Manager. This is very well known, and as we can say that it is the control plane of Azure. It works like a central management layer, and every single operation uh, that you uh, that you perform, either you are creating something or updating, deleting, whatever option that you perform, it must go through the Azure Resource Manager, right? As you can see, uh, whatever interface that we are using here. So it could be Azure Portal, it could be PowerShell, CLI, REST clients. These are all user-friendly interfaces that we use. Behind the scenes, these all interact with uh, Azure Resource Manager and get converted into a ARM API call. And that's how the operation will proceed. So, uh, and the next thing, the next thing that we need to understand is the hierarchy. As you can see in this image, so this hierarchy is very important. This is how resources are managed, right? This is a fixed hierarchy. We have the management layer at the top, then we have the subscription, resource group, and finally the individual resources. This is important because permissions flow through this, right? A permission is in Azure are managed through the role-based access control, and these permissions flow this particular hierarchy. The hierarchy is very critical. Let me repeat that again. So whatever permissions you apply at a higher hierarchy, it would be passed down to the lower hierarchy. For example, if you give an account uh, owner level access to the subscription level, right? If you assign a user to be a owner of a subscription, whatever resource group is created under that subscription, that user will be owner of those resource group as well. And understandably, all the resources under it as well. So once the upper hierarchy has certain permissions, the lower hierarchy will follow it. In the same context, if there are multiple subscription and the user has no permission for it, they won't be able to do anything out there, right? You only get to see what you are assigned to see, nothing else, right? Next thing, now that we understand how a resource manager actually works, let's try to understand the API access process, right? The ARM API access process, how it works. As I've already stated, that uh, access control is handled via the RBAC role uh, based on the uh, based on the access control. And every time you make a request, any request that you are making, it is evaluated based on three things. Listen carefully. So three things are evaluated. The first one is the identity, which is who you are, right? Second thing is the role, what you are allowed to do. And the third thing is the scope. What are you actually trying to, where are you actually trying to use that particular permission, right? This matters very much. The scope is very important. Only if you, uh, only if all of these three things are aligned, then you are granted the access. And here's the thing, you can always get an ARM token, right? Even if you don't have any permissions and you don't have any RBAC permissions, or even if you don't have a subscription, doesn't matter. Azure will still issue a token, but this token is supposed to be useless. Why? Because you don't have the permissions, right? Well, you are identity. You logged into a tenant. Very good. You have but you don't have a role, but you still got a token, which is useless, right? So this is our assumption as of now, right? Take it as an assumption. This should work. This is what we are made to believe, but this is where our assumption will be breaking later, because we'll see how some of the API do not enforce uh, the theory that we have just learned, right? So as you can see in this example, here I am making a post method call to a Microsoft.web ARM provider trying to list the app setting, right? And I have failed. It's saying that status is 403, so it's unauthorized. The user account, which is my own account, is trying to list the app setting, but I don't have the permission over this scope, right? That's why I was not able to do it. So the three pillars, remember, the identity, the role, and the scope. All of these three things matter. Like I might have the permissions to do it at some other web application, but for this one, it was not possible, right? So I think it's very clear how ARM API access work. Next up, we'll talk about guest user. So what is a guest user? So guest user is the main actor in our attack path that we'll be seeing. Like call him a hero, call him a villain, depends on the perspective. If you belong to the if you are a red teamer, you might call him your hero, or if you're a company getting exploited, then obviously you won't like him. So we need to understand what all they can do, right? So a guest user is someone who is external to your tenant. They are invited, right? They are invited to that particular tenant. Uh, Typical examples could be a contractor, a vendor, or a partner, right? You might be acquiring some company and you might be inviting those to your main company as well, or you might be working as a freelancer. Could be anything, right? The thing is, they are heavily restricted. Now, what do I mean by that? Let me show you. So, as in the screen, you can see, uh, you'll see that the assigned role is zero, right? The assigned role, it's zero, uh, and the user type is guest, right? So this clears that the user is guest user in this tenant. And by default, guest users are heavily restricted. They can do a few things, like they can manage their own profile, uh, change their password, but there are a few things that they can't do. They cannot enumerate the full directory. They cannot see any resources. They have minimum visibility. But what can do then? Like, what can they do? Like, why are they here then? So there are a few things that they will be able to do, which is they exist in your tenant, right? You have invited them, so they will be there after obviously accepting the invitation. So they exist in your tenant. They can authenticate, they can authenticate to your tenant, and they can switch there. Like I said earlier, Azure will issue a token no matter what. So even if you don't have the RBAC permissions for this tenant, you will still get a token. But that is supposed to be useless, right? Well, we'll see that in a while. Talking about the guest user, it is important to understand the authentication process, how it works for guest account. So authentication for the guest user is a bit different from the regular user. They are a federated identity, as you can see. So they are a federated identity and they log in using their home tenant credential. Listen very carefully. The guest users log in to any other tenant using their home tenant credentials. Just because they have been invited to some other tenant does not mean that they have different set of credentials there as a guest. So no credential is issued by your tenant. They will be using their own credentials from wherever they come from. And like in the image, you can see the identity is federated. And since it's a federated identity, your tenant will be trusting the user's home tenant to handle the actual login process. Okay. The guest tenant won't be handling the authentication. Now, once the authentication is done, right? Once the user logins, then only the guest tenant takes over, and it will use the RBAC permissions, the role-based access control permissions, to decide what particular operation can this user do in my tenant. I hope everyone understood that. So what do? We basically invited a user and we didn't give him any permissions, as we saw, right? They were able to log in using their home tenant credentials and they exist in our tenant. That's it, nothing more. And as you will check in the issuer part, right now is external Azure AD. That gives us the idea who handle the authentications. So the external Azure AD is handling, which is the external tenant. And it could be anything else, it could be Microsoft account or google.com. Depends on how you have invited the particular user. Since that is done, let's move to the another crucial concept that we'll be looking: tenant boundaries, right? Supposed to be strict. We like everyone is hearing that uh, tenants are isolated and like tenant wall has a boundary that isolate two tenants and the resources, groups, users, whatever object that we have in a single tenant is completely separate from the other. That is the theory, right? So if we talk about the theory, uh, a user from tenant A should not have same level of access in another tenant, right? Even if they are invited or they have certain level of access in their home tenant, they don't carry over those permissions. That is not possible. One needs to be granted the permission to do anything, right? So this is the core assumption. This is the security assumption that we have. And the whole trust model of this tenant and cross tenant process is built upon the idea that tenants are isolated from each other. Now let's apply a scenario to it. So even if I, as a user, if I get invited to your tenant as a guest, I should not carry over my access, right? I might have like suppose that I'm global administrator in my tenant. Do you think I'll be a global administrator just because you invited me? No, right? It should not it's not be like I should not be able to do that. I should not be able to see any configuration or any changes that I made in my home tenant, right? What I did in my previous tenant stays there, right? Listen to it again. Whatever I did in my previous tenant should stay there, and whatever I do in your tenant should be controlled by the rules that you assign to me, nothing else. Yeah, but there are certain anomalies to it and we'll be looking into it. That's why a condition applied mark is given there, right? So as you can see, if you don't if you don't send boundaries, people don't know where to stop, right? That is very true, especially the domain that we work in. People are always trying to find some kind of bypass or misuse the legitimate services, breaking guardrails, trying to find information that they should not, right? Finding the meaty stuffs. So it's a big problem out there. That's why building a guardrail, building boundaries, it's very important. And especially in Azure, the tenant boundary is very important. Okay, so let's take a look at a decoded access token, right? So if we look at it, let me get the pointer. Yeah, so if you look at it, the audience is management.co.windows.net. So it is for Azure, and the issuer, it is this is the tenant ID. As you can see, the TID value here is the same. So effectively, what we can understand, if we decode the uh, uh, ARM access token, which is basically a ZWT token, it will show us the claims. Whatever claim that particular token holds, it will be showing it, and we can view the exact things that it can do. For example, uh, as you can see in the UPN, it's saying the guest at Red Labs guest. So this is a particular user account for which we are giving these permissions, and the TID is showing as well, right? So this is scope to a particular tenant, and we should be only able to use it for the resources present in that tenant and nothing else, right? So this should not work for any other tenant. Like I think that is pretty clear, right? So the whenever you try to perform an operation, the Azure Resource Manager will check the TID in the token, and if it does not match, it will surely fail. One thing should be clear, right? So the role-based access control does not carry over the tenant boundary, as I've already said. And if I had certain roles, it will stay where it was assigned. It's not transferable. So uh, that's how the structure of the JWT token is. Next, so far so good, right? We saw how the tokens are scoped and everything is rock solid. Tokens are scoped to tenants and boundaries are expected and everybody is happy. But here is where the things gets very interesting and a bit dangerous, right? So there are a few ARM endpoints which we call the global ARM endpoint, and they break this model, right? They do not follow the hierarchy, as you can see in the image. They like whatever permission model that I just explained, they simply don't care. So for a normal API, they would be scoped to at a particular scope level, right? But global ARM endpoints, they are not bounded to any of this. They don't rely on this traditional role-based access controls, and they don't care, right? Frankly, they don't care. So what is the issue with it? Like there must be some issue that we are calling it out, right? So when you try to access these endpoints, uh, endpoints, they return the value, right? As if they were uh, sending it back to a user where it was configured for. Let me uh, put you to a perspective. So when these endpoints are accessed using a guest user credential, right? If we access out these endpoints using guest user credential uh, from a tenant where you are invited to, right? Where you are a guest, they would what they would do, they would return the configuration as if the user is actually in the home tenant. We saw how these tokens are scoped, right? So if we use this token to call a particular endpoint, this should not be returning the value that belongs to another tenant, right? That should not be possible. So if you're in a home tenant, right, even though user has no role, no permission, this should not be seeing anything, right? Since we don't have the permission, we should not be able to see any of this configuration, right? To make it more concrete, suppose you use your personal account to set up a deployment credential for a web application. You configure that in your home tenant, and now imagine that you work as a freelancer and you were invited to another company as a contractor. Now you are a guest here. You don't have any permission. You don't have any RBAC permission. You don't have nothing there. So when you try to call these endpoints, you will be seeing the configurations, the settings that you actually configured in your home tenant, right? We are using a token that is scoped to some other tenant, but effectively we are getting a data that we are not supposed to get. right? That is the issue with this tenant, with these endpoints, right? So basically, what is happening is we are getting cross tenant data, and this is by design, right? This is by design itself. We are not doing anything else. We are just calling this endpoint. Now that we have talked about what these global endpoints can do, let's take a look at them. So uh, these are the two global endpoints that we will be using today. The first one is the publishing user. So the publishing user endpoint is used for managing user level credentials, right? Uh, what do I mean by user level credentials? So we'll be talking about this in a very detail. But in the meanwhile, let's see what we get, right? Let's see what we get when we call these API endpoints. So what is the hype that I'm creating? Let's take a look at it. So here, when I do a get call to this publishing user endpoint, you will see that we are getting some pieces of information, right? So what is there to worry about? Is there something risky, or is there something interesting? Well, there are a few things that we'll be looking. So I have marked there the publishing username. As you can see, the publishing username. So this is the user scope. This is a user scope credential that uh, that is managed by the publishing user endpoint. Now we'll be talking about in detail, right? So just remember that we are getting a username by calling this publishing user endpoint. That's it. And the next one is the source control endpoint. So this is also the part of Microsoft Web ARM provider, and this will be listing the this is used to configure source controls. Source control could be GitHub, Bitbucket, and various others. So whenever you are making a deployment using any of these source control, uh, this will list those configuration for you. So again, what is the hype, right? There must be something. So let's see the output. Okay. So in the output, you will see that we are making a GET request to the source control endpoint, and we are getting a few configuration. I have cropped out the image for visibility, but there are a lot of other options that we will be seeing during the demo. The first one is the GitHub, and the second one is for Bitbucket. In the GitHub section, if you will check, I have marked a particular point there, right? We are uh, we are getting a token there, right? So, but why? Why are we getting a clear text? Why are we getting that in a clear text, right? So it's an issue by design, right? It's a design issue. So here right now we are getting a GHS token. So why are we getting it? So whenever you, as I've explained, when you configure the deployment, this is the endpoint being used, and GitHub on be and sorry, Azure on behalf of you stores this token for authentication purpose, to use it for authentication when talking to GitHub, right? That, that's the simple definition of it. So it's not an issue that it's storing the token, right? Because we need to have some automated process. A user can't be involved every time a deployment needs to be made, right? You might be changing the codes, and you don't want someone to be there and actually insert the username and password to authenticate all the time. That is not the issue. The issue is that it is stored in a clear text. And the further issue that we also saw with the previous endpoint, this was not configured in this tenant. The token that we are using for the token that we are using for a tenant, this user has no permission at all. So how did he configure a web configuration? That is not possible, right? This was done somewhere else. But using the guest account token, we were able to get it. So you are not seeing the header because I'm using the is it REST method out there. So we are getting this information, that to very critical piece of information, which should not be in clear text, that too using some other tenant credential, other tenant token, right? Right now you are seeing a GHS token. We'll be talking about this in very detail uh, when we talk about GitHub tokens. So uh, one thing that I would want to mention is that in real world context, right, when you're working with these endpoints, you will be probably seeing a classic token out here, which will be a GHP token. So we'll be talking about in a detail. So just remember that. And the GHP token is far more dangerous. It's very dangerous. It has very broad permissions. And when you are working with it, right, when you are seeing the scope of this credential during the mitigation phase, you will realize how broad they actually are. And this is not just the case with GitHub. Okay. So as we saw, it's the same for Bitbucket, any other solution that we'll be looking into, right? So like Azure is storing this on behalf of us, right? So these are stored for automation, for pulling codes, and then pushing changes. The issue is not that. So the only issue that we have right now is that the token will have very high privilege, and that we are getting this in a plain text, right? Now these two are not the only endpoints that we have. There are others as well. So talking about the tenants endpoint, uh, so for like if we talk about the tenants endpoint, it's kind of a benign or like kind of a normal thing, but uh, it would give you a list of tenants that a particular user is part of, right? And when like you can use any tenant access token for this to work. You log into a tenant, and then when you make this API call, you will get the list of all the tenants that you belong to. So it basically helps us for more enumeration, even though it's benign. Suppose that you were somehow able to get access token for a user, you can map out what all tenant that user belongs to, right? So for example, in this image, you can see the user belongs to two tenants, and one is in Singapore and second one is in India, right? It can help us further uh, get more information about a particular target. And since we are getting information about the tenants, we can try to target the other tenant, right? Why? Because not all tenants are equally secure. There might not be security defaults enabled, or there might be loopholes in the conditional access policy, a lot of things that goes with identity security. So these can be checked out. Okay. So let's talk about basic authentication, right? So talking about basic authentication, if I had to give you a simple single diagram to show it, this is it. There's nothing else. Like we don't need to understand it. If you look at this, you know what basic authentication is. So I guess I won't have to explain it. I'll just go to the next topic, right? Well, no, I'll explain it a bit. So talking about basic authentication, Azure App Services provide authentication for FTP files, right? So basic authentication is basically there for FTP and for web deployments, right? Since it's easy to use, you just need username and password. It's easy to automate, so people use it. And like, uh, so these are easy to use. Uh, One thing that you need to remember is that it is now like by default it's disabled. Microsoft is trying to push it out. So whenever you try to create a new web applications, it is now disabled. But that does not mean that it's not enabled or it's not used out there, right? There may be old applications that had basic authentication like on by default, or some other companies might be using it because of the ease. It depends on the business requirement and basically the architectural need. So, so there is a high chance that we can, make an educated guess that uh, it might be enabled. Now, talking about the basic authentication, you need the username and password for it, right? And there are two type of credential for it. So the first one, these are called as deployment credentials. And as I told you, we will be talking about deployment credential in a while. So here it is. You will be finding this in the FTP tab when we're talking about the deployment center. This was in the FTP tab where we could see it. So the first one is the application scope credential, right? So as the name suggests, these are scoped to particular application. These are created along with the web application, and are particular. So these are fixed to an application or a deployment slot. These are auto-generated and can't be configured, but we can reset it, right? We have an option for that. And the second one is the user scope credential. So this is the one that we are actually interested in. Uh, this particular credential is directly tied to your account. right? It is not just to a specific app. Let's take a look at it. So these are the single credential for your entire Azure account. And so let me repeat that again, okay? So this single set of credential can be used to manage any application in any subscription across all tenants where you are authorized to do so, right? That last point is very important. So as you can see in the image, it's saying that user scope credentials are defined by you, the user, and can be used with all the apps that you have access to. Okay, fair enough, right? It's informing us of the importance of it, right? Great. But this is what you will like. This is what you will be finding under the deployment center, the FTPS tab, and you can change this, right? You can change this credential under a specific application. As you can see, we have an option to reset it as well, and you can change it. But the strange part is that by just changing it under one application, you are actually changing it globally. This is a very important detail. So, which is like somewhat which is somewhat missing from here, right? This is the important detail, and it should be added here, right? This could be used anywhere. When I say anywhere, I mean anywhere, right? So if you look these information are actually present in some of the documentation. So if you check a Kudu wiki, Kudu will be talking about in detail in a while. So if you look one of the Kudu wikis, you will find that it's clearly written that the credentials is tied to a particular user account, regardless of the Active Directory, and are not particular to a web application, right? And I think this information should be added here as well. Why? Because suppose like you are working for a company, right? And uh, so sorry for that. So suppose that you are working for a company and you have certain amount of permissions out there. So you might be a developer and you manage the web applications. Now, when you suppose that you change your company, you started working for some other company, and uh, somehow that company got acquired, right? So that company got acquired, and when you were trying to manage the web applications there out there, and since your account was they transferred there, like it could be used as a guest, right? And the user scope credential got reset. If it is reset out there, you will be actually logged out. So you didn't do it, but somebody did it. Somebody reset it for you. Now you won't be able to access it. So effectively, you are able to use this in any subscription in any web applications where you have the permission to do so, and that permission is website contributor role, right? So you might be working with different companies, and you might be having same permissions out there. This is the same credential that we will be using there. Okay, next up we'll talk about the GitHub access tokens. So as we have seen already, right? How these get integrated with GitHub, like how this integration works during the deployment process. And we saw how, like, we understood how it is specific to Azure Web Apps as well. So GitHub Access tokens are effectively our credentials, which we use instead of username and password when we are authenticating with GitHub. And they are using CI/CD pipelines. So they could be used for deployment scripts or uh, Azure's own integration. So when Azure set up the GitHub connector for the automatic deployment, it was storing a token. As we saw in the previous slide, it was storing a token to authenticate on behalf of us. Now, understanding this token will help us understand and what an attacker can do, right? If they find one, or from an attacker's perspective, you might want to understand the scope of damage that you can create by having this token. That's why we are going to look into it. And so there are different types of it. The first one is the GHP, which is the GitHub personal access token. They are of two types. So the first one is the uh, classic personal access token that Azure during the deployment process when you use the Azure portal, and it has very broad permissions. That token has organization-wide permissions, right? And the second one is the fine-grained access token. So As the name suggests, we can actually scope it. So we can configure the individual permissions out there, and we can scope it to particular repositories, like different numbers of it, public, private, whatever your choice is. It's very manageable. The second one is the GHO. GHO is for the OAuth access token. It is used when the OAuth applications act on behalf of a user. So these typically have shorter lifetime. Next is the GHU. So this is a GitHub app user to server token, right? So we are using this to access resources on behalf of a user. Next one is the GHS. So we have already seen this. Let me take you out there again. You see this, what I was talking about? So we have seen the GHS token. So the GHS token is the GitHub app server to server token. These are also called as installation access token. And this is used for automation process, right? Where no human involvement is needed. It allows GitHub to access repositories and perform actions like cloning or pushing a code or making deployment, that sort of things. Next up is the GHR, which is the refresh access token. Sorry, refresh token. These are long-lived, and these are used to get access token without needing to re-authenticate, right? Just like we have the access token and refresh token for Inter ID, it's a similar case out here as well. So why does this matter? Like, why are we talking about all of these things? Because we already saw the source control was storing this token and it was returned to us in plain text, right? So if an attacker calls this endpoint, they do not just get the token, they will put in, like, it's not about just the token because it's the scope of the token. This will allow you to move from a particular, like we were just talking about Azure, now we are moving to the entire new space, right? They could be like destroying your CI/CD pipeline itself. They could read your source code or push malicious commits to it. Right now we are seeing a lot of cases of supply chain attack. So these are a very relevant topic. Or they can interfere with your like GitHub deployments, as I said. So the radius depends entirely on the scope of the token. And as I've said earlier, since we will be getting a classic token in a real world scenario, it's over the entire repository, not just the public or private. You can disrupt the entire organization using it, right? So I hope you all understood that. So next we'll be talking about Kudu. So what is Kudu? Sounds funny, but it's an important thing. It's an open source engine that powers some of the deployment within Azure App Service. And so basically, when you create a web application within Azure, uh, a Kudu website is created as well as a companion, right? This companion site is called the Kudu service or Kudu site. The best way to look at it would be to call it a buddy site, right? Since it's getting created with the app. Uh, this is a buddy site to the real web application that we'll be using. And as I've already explained earlier, that the actual infrastructure that will be holding our web applications uh, are managed through the Azure App Service Plan. And since Kudu is also a site, right? It requires some kind of compute. So this is also accommodated in the same. This is also accommodated in the same app service plan. So if you are creating multiple web apps within a single app service plan, you would need to take this into consideration. So whoever is responsible for creating this app services, they need to take it into account. Another thing that I would like to point out is that there are certain limitations to how many web application a single app service can handle. So if we talk about the free plan, the F1 plan, the app service plan out there can host 10 web applications. That is the max number according to Microsoft documentation, right? So let's get back to talking about the Kudu. So it is responsible for deployment and running web jobs, providing deployment diagnostics, and one more thing, like there are a lot of things. Another thing is that it provides full access for file system of the actual web application itself. So there are other various features as well that Kudu exposes, like Git integration, and like it has also option for zip deployment. So you could have your entire code base in a zip file, and then you could directly deploy it, right? Uh, for that, you can use a specific API endpoint as well that is exposed by Kudu service, which is API/zip deploy. All of these informations are available in the Kudu wiki. You can check it out. There are other options as well. Like for example, if you have multiple deployments, right? You might be using deployment slots. So one could be for your testing and second could be for your production. So you could check those using the API/deployment. This would list all the deployments that you have, or you need specific information about a particular deployment. You could use API/deployment/ID using the specific ID to get the information. So there are other API endpoints to it as well uh, that help us with the deployment process. Along with that, we have something called as deployment hook, web jobs, and most crucial thing that is accessible using the Kudu is the environment variable. Okay, this environment variable is the actual context where our web application would be running. Right. So along with that, we can also get logs that are, as I already explained, the actual application log that could be used for diagnostic. Now, think from an attacker's perspective, right? If we gain access to Kudu through through whatever means, right? We might be using GitHub, like we might be using basic authentication, or we might be accessing it through some intra ID that we were able to get access and bypass MFA if possible. This would be a very big thing, right? Reading the environment variables, connection strings, secrets, source code, whatever is possible from the Kudu, right? You can also check other integration there out, like it also has other integrations which you can check as well. Like there might be some custom web job running, right? There could be a hybrid connector connecting the website to an on-prem system, like possibly leading to a cloud to on-prem attack. So there are a lot of possibilities. And another thing is that uh, there is another specific endpoint that I would like to talk about, which is API/command. So to access a particular access a particular web app within Azure, all we need is the web app name, right? So web app name .hcm.azurewebsite.com, and sorry, the website name .azurewebsites.com. That would give the website. And similarly, to access the Kudu service, all we need is to insert the HCM word out there. And using this endpoint, there's another API that is exposed, which is API/command. So using this command, we can make post call. We can run any arbitrary code and get its output, right? Which is a very big thing. And another thing that I would like to address is that we need to have a minimum of website contributor role, right? A minimum of website contributor role is needed to access Kudu. Even if, like as we saw earlier, like even if you get a user deployment credential for a user account somehow, and you uh, identify a particular web application that you might be able to use it, if that user is not does not have the minimum of website contributor role, you won't be able to access it. It's not possible, right? uh, that is the end game for us. We can't do it. So now let's move on to the next one. Just a second. So let's look at the Kudu interface. We have talked about Kudu a lot. Now let's see what all we have there. So as I've explained, we have the Azure App Service, and we are accessing the Kudu portal for it, the scm.azurewebsite.net. And As you can see, we can check the environment, which is where we get system information, app settings, connection strings, uh, environment variables, and whatnot. Similarly, we can check logs for deployment and actual application. And one very important thing is the SSH option, right? We get to SSH into the actual container that holds the application, right? Which is a game changer. If you get to access the kudu, you basically get access to the application. And similarly, we have other options as well. Like you get the file manager, where you will be see the where you will be able to see the entire file architecture of the application. So this is very lucrative, right? Once you get access to kudu, you will be able to do uh, a lot of things, right? Uh, so now let's move to the next one, move to the next topic, which is Terraform. Now we have been talking a lot about websites, deployment, CI/CD pipeline. So we need to discuss Terraform, right? Uh, because it is very common in deployment environment, and so yeah, we need to talk about it. So it contains or like to talk about to talk about Terraform, it's a in fact it is a infrastructure as a code, and it might contain or it contains or might contain sensitive data. So because it helps us to create resources using declarative language, there might be some portion of sensitive data out there, right? So anything that contains sensitive data or has slightest chance of giving us something that we can exploit, we should check it out, right? So as I've said, it is an infrastructure as code which help us manage resources using declarative language, uh, using the configuration file. So there are a few critical artifacts to it. The first one is Terraform TF state file. So these are called as the state file. Uh, these files are used to store the resource ID, metadata configuration, and very often can contain sensitive information like it could contain a connection string, could contain a password, right? So it's not that this file is malicious. There's no malicious intent to it. Terraform needs it, right? Terraform needs it genuinely to check what has been already deployed and to make incremental update, right? So consider that you are you are creating some certain resource, and then if the incremental is the deployment is not incremental, it would create those resources again, which might not be something that you want, right? Next up is the TF-var file, right? The This is the variable file that Terraform uses. This is used to store variable values that is stored separately from the main configuration. As you can see in the example, we have a variable called location with HTOS location, resource group name, app service plan name, similarly web app name. So in a real in a real environment, it can contain some environment specific secrets, right? Like for example, if you are trying to enumerate certain resources and you were able to get some kind of name like web app name or resource group or subscription ID, that might help us a little, right? So if you are used like for example, if we are using Terraform to create a user account within Azure, then the variable file can very well or might store the actual username and password itself, right? In the variable file. This all depend on the situation. So from an attacker's perspective, uh, we can so from an attacker's perspective, if we can access certain resources related to Terraform, whether it's the main configuration file or these two files that I'm talking about, it would be very beneficial for us. Like, well, because we'll be potentially getting more pieces of information that, like, even without accessing the actual Azure environment, we'll be getting a piece of information from there, right? Considering that the configuration is made such that. So, and one more thing that it's very common that these Terraform configurations are stored within cloud solutions, right? Cloud storage solutions or GitHub repos or storage account. Why? To maintain synchronization within an organization. For example, if we take an example of DevOps team, that might be working on a particular project. And if everyone is storing this configuration locally, it would be very hard to synchronize and understand what all resources have been deployed out there. Why? Because the context is there stored locally. So they would upload this to a cloud container so that entire team is in sync and the incremental update is happening out there. So if we are able to get access to certain GitHub repos, it would be greatly beneficial for us, right? And we will be seeing such a scenario in our attack. So one more component before we, tie it all up together, like tie it all together. We'll be combining everything together, and we'll be moving to the next part. So this is the Logic app. So the Logic app is Azure's workflow automation service. This lets you connect multiple systems, could be SaaS applications or Azure services without writing any complex integration code. So that is the selling point of it, right? It helps you writing low to no code. So, so basically, a workflow in Azure contains three major components. As you can see in the image, we have three components out there. So we have so the first one is the trigger, right? Uh, the first one is a trigger. So this could be an HTTP trigger, or could be timer-based event, or could be a queue message. There are other options as well. So basically, this tells us what will make this logic app fire. The logic that we have, what will make it fire. The second one is the action. Right? For our example, it's get a secret. So what actions are executed once the logic app is triggered? It could be calling an API or sending an email or transforming certain data, depending upon the case. In our case, we are getting a secret, right? So we could be getting a secret from where? It could be a key vault, right? We could be getting certain information from a storage account. So for that, we need a connector. That is a third part. So connector is the bridge between external systems and the logic app. It could be like, for example, a connector between key vaults, as I've explained, or we might like, or it could be between a storage account, it could be a third party API, or we might have some kind of 365 connector, right? So all of these connectors work under a certain logic. How? As we have discussed, everything in Azure works with some kind of permission. And for the logic app to get this piece of information, like be it key vault or storage account, you need the permission. Like for example, to actually get a secret, we would need the key vault secret user, right? Or any other broad permissions. So the connector is helping us in such a way that logic app becomes relevant, right? Relevant to our context, to the enterprise environment. How? As we talk about, like as we talk, that website is not an isolated thing, right? Behind the scenes, there could be multiple things working with a single web application. There might be a function app, there might be a database, there might be a logic app functioning. You might be using certain component of your website to just send emails, right? And you might be offloading that work to a logic app, or you might be storing certain certificates within your key vault. So overall, everything is very integrated, right? It is not just a single application out there. Okay, so now that we have covered all the building blocks, when we now know, we will now move to the demo part. So before that, I'll explain the scenario to you all. So the scenario is, we have a user account that belongs to some other tenant, and somehow we were able to invite that user. We invited that user to our tenant, which will be a guest tenant for that user, right? Since he is not the original member. And somehow we were able to get the username and password, right? We were able to fetch the user, we got the username, we got the password, but we were not able to access the user's home tenant. Why? Well, MFA, right? We were not able to evade the MFA and we got stuck, right? So that is the entire context we have. We don't have anything else. So from an attacker's perspective, all we have is a valid credential and the guest tenant that we have created. Using those two things, we will be seeing how we will pivot from one tenant to another and effectively getting a high target flag. Okay, so before I take you to demo, uh, let me uh, show you guys the our Red Teams Lab platform. As my co-host it is stated earlier that we will be taking you through a our Red Team Labs portal once. Okay, I hope my screen is visible. Let me increase it a little. Okay. So this is our redteamslabs.enterprisesecurity.io, the Red Teams Lab portal, as we say. So starting from the home tab itself, you can see that we clearly state what all labs we have, the online students and total batch issued. Along with that, we have various categories of labs and challenges that we have, right? So Logic App, Key Vault, Azure Ready, storage accounts, Bark tools, automation accounts. So talking about the automation account, this was released as a part of our Azure Red Team month, but well, it was uh, part of it, but it was like announced before it, pre-hand. So this is the newest lab that we have. Along with that, we have the new premium lab section where we have the labs that we are explaining or showing to you during the webinar. So the first one, which is the averaging BitLocker key, was done by my co-host Sitish, and second one is the abusing Copilot agent that was done by Vishal, and finally we'll be today looking at the global arm API abuse. So we have a very intuitive platform out here. We saw the recent added labs. As you can see, the most recent one is mine. On top of that, we have something called as a student VM. So what we can do, suppose you are new to our new to the Azure space or new to our portal itself, and you have no idea how to you are going through the walkthrough solutions, but you are not able to run certain commands or got stuck something, you don't have the exact setup to do it. This section will guide you through it. We have all the information that you need to work with any particular lab that you want to solve here. This is for both Windows and Linux. We'll help you through it where you can install everything that you like and you can proceed with it. You won't be stuck anywhere. Second thing is the leaderboard, where you can actually see your progress, right? Uh, you can see where you stand, how many labs you have solved, and other pieces of information. Next up, let's talk about badge. So we have a lot of badge. This could be like for streaks or you know for individual the labs that I was showing, the like for logic apps, automation account, or the intra ID and other kind of stuff. So when you click on the all labs, you can filter it down. You can filter it down based on the individual services or based on the kind of attack that you are looking for. For example, if you're looking for discovery and recon, you can solve these labs. And if we talk about just a second,
So hi Prajwal,
yeah,
there's an issue with the screen. Can you reshare it?
yeah, sure, just a second. Sorry for that. Let's stop my sharing. Okay. Uh, can you see the my browser out there? It
Yes, we
is.
can.
Hello.
Yes, we can see your screen. It's visible. Thank you so much.
Yeah,
Please proceed.
yeah. So okay, let's continue. So we saw the different categories of lab that we have, along with the type of attack path that you might be looking for. So, for example, if you click on initial access, let it load. We'll see all of these labs are based on initial access technique, right? Let's check one of the labs, right? So let me open one of my favorite labs. Uh, we'll go to Bark Challenge 10, right? Let me show you how it works. Me increase this a little. Yeah. So if you open a particular lab, you can see we have enough information to guide you through it. So in the overview section, you will see the scenario uh, and all the theory related to the app that we theory related to the attack path that we have built. You won't have to worry about going and finding those information out there. And on top of that, we are very generous. So we have hints as well. And talking about the informations out there, you can if you are confident or you have knowledge about the context that we are talking about, you can just click on start lab and continue with the lab, or you can view the attack path that will explain the flow of the attack that we are trying to demonstrate. And if you are not so confident, or if you are new to this portal or new to Azure itself, the red teaming, uh, the red teaming domain, you can check the exploitation tab, and we will guide you through each and every step along with the related information that why we are doing a particular like why we are running a particular command and what we are getting to guide you through the entire process. Okay. And on top of that, like our development team works really hard to keep these things to keep this thing working and running. And we have something called as the platform status, where we show you the latest changes. Like for example, if you see challenge logic app 8, 9, 15, and 25 are currently disabled. We are sorry for that, but there's an ongoing update. So anytime you have any issue, you can also use the Red Labs platform, Red Labs Discord channel that we have, you know, uh, that we are using to chat right now to inform us about it. And you can go to the change logs to see all the changes that we have made. Right. So that would summarize the that is our portal. Next thing, we will be moving to our lab itself, to the demo part, the one that you are here for, right? Okay. So we have a piece of information, right? That we have a user account, we have a password. What else? Let's see what else. Just give me a second. Okay. So let's start like a complete beginner, right? We have a username and password. Let's try to log in. So we have the username, we have the password. Let's try to sign in. Okay. I think the demo is over now, right? Like we got an MFA and we have no way of overcoming it. I think we can close the demo, right? But no, don't worry. We still have few options for us. One thing that we can try is that if the security default is disabled, right? If the security default is disabled, then we might be able to get the outcome that we are looking for using the CLI. So let's try that as well. Connect AZ count, enter, wait, and we'll try to log in again. right? Same thing, but we'll do it again. Let's see. Let's do the same thing and hope for different outcome. Okay, so it's not possible, right? We are not able to do it. Uh, we feel stuck now. But as I mentioned earlier, we had one more piece of information out there, right? Which was the tenant ID. So what we can do, we can try to connect using that tenant ID. We'll specify the tenant field. We'll get the tenant, we'll paste it, and now we'll try to log in again. So now when we try to log in using the username and password, sorry for that, and password, sign in. Okay, there's a great news. The great news is that this particular user account is able to log into the tenant that that we maliciously or intendedly try to invite that particular user and then get a hold of him. And it worked. Why? Because we are the one doing it. So it's asking us to set up an MFA. We'll be doing that. Let's click next. Let's wait for a second for it to complete. Okay, so we'll set up the authentication. Let me set it up. Give me a few seconds. Stay with me. Okay, I'll verify it. Okay, it's approved. We're waiting it for it to get the confirmation so that we can proceed. Okay, it's done. It's a great news for us. So even though we were not able to log into the home tenant, we got popped up for the MFA, and we had no way to bypass it. Now we are able to log into at least one of the tenants that user belongs to. Okay, we got a tenant, but we were able to log in, but we don't have a subscription, right? So what else can we do? Like, should we end the demo now, as I was trying to do in the first step itself? Well, no. Like, since we don't have uh, anything related to subscription name, what we can do is we can try to use our big brain and think like what all we studied, like what all we went through during the theory part. When I was going through this theory on and on and on, and you guys were listening to it, there were a few points that I mentioned, right? And there were some specific points that I was repeating again and again, which was even if a user has no subscription, nothing at all, no permission, even then we were able to call certain APIs and get few pieces of information which belong to their home tenant, right? Now we will be viewing those. Okay. But before that, let me actually, show you guys what I'm speaking, right? So that, you know, we have the actual thing that we need. We will validate things. Get the access token, we'll copy it, and we will open the browser that we had. Just a second. Yeah, we'll open the browser and we'll go to jwt.ms and we'll decode it. Okay, let's decode it. So as you can see, this is issued for this particular tenant. Let's verify it, right? Let's not leave anything unattended. 3ABD, 3ABD, right? Same thing. We have password, MFA, and our user, right? It's confirmed that this particular user is acquainted as of now to this tenant, and we have a authentication. We have authenticated for for this tenant, and whatever access token that we will be using further will belong to this tenant only, right? That is fixed. So right now we just have the tenant ID. Let's get the name of it, right? Let's get the name. So I'll clear this. I will paste this command and we'll get the name. So as I told you, it's the Red Team Labs guest tenant, right? We are belonging to this tenant and we have no permission whatsoever. But like we talked about something, right? We talked about an endpoint, uh, which is the source control endpoint. And there was something very interesting out there, which was access token, right? So let's take a look. Look, can we actually get it? Like whatever I was explaining, is it true or not? Trying to find out. Okay, as I told you, there will be a lot of options out there, a lot of configuration. So for OneDrive, we have for Dropbox, and then Bitbucket, and finally GitHub, right? The GHS token that we have been going on and on about during the theory, it's finally here. So, but what can we do with it? Like, is it like interesting? Let's check. Like, how can we use it? One way to use it would be to make a direct API call to GitHub API. What I personally like is to use a variable which is gh underscore token, where we will configure this particular token that we have, and we will like once we configure this particular token, let me actually validate something for you. So gh auth status, as you will see, without the environment variable. So this is a different session. Without the environment variable, the GHCLI won't be able to get any auth context. But once we set up the GH token with the GH variable with the token that we have, like something interesting might happen. So the GHCLI would automatically, we are not logged in, just a second. Okay, I made a rookie mistake. Let's fix that and try again, right? So if we check the auth status now, let it process for a while. Fail to log in. Just give me a second. Copy it, I'll paste it. Then get the token again, paste it, and then we'll check the GH auth status. Okay, great. I was scared for a moment, you know. Thank God the demo gods are with me today. So okay, we have an access token now, and you can see it's a bot token. Why? As I previously explained, the GHS token is for server to server token. It is used for automation process, and it is used by GitHub applications. So the GitHub application name is Global ARM Labs, and it's a bot, right? So what can we do with it? So I think everybody working like in our domain or any technical domain, to be precise, uh, whenever we are working with GitHub, one thing that is very common, or the exact thing that it is used for, is a repo, right? Let's say if we can list a repo or not. Repo list. Great, great. So we have one repo that we can access, which is global ARM. Let's call it Juice 1930, which is a private repo, and it was configured 25 minutes ago. So we might be finding some freshly updated information out there, right? So let's clear it and we will check the repo list again. And next thing that we will try to do is clone it, right? Let me shift to somewhere else. Now what I'll do, repo clone, and I'll copy the name. and I'll try to clone it. Let's be very hopeful that it will clone and we might move ahead with something. Okay, great. It was cloned. So let's check the content of this particular repo. CD clear ls. So we have three pieces of information, right? And as you can see, we have a main.tf file, readme.md, and variable.tfvars. And I've explained during the demo part that it could open a lot of doors for us. Now it's time to see if I was speaking the truth or not. So let's start with the first one. In the main.tf file, if we check, it looks like a configuration to create resource group, app service plan, web app, and then what else? Well, nothing that interesting, right? It's just showing us the output URLs and other pieces of information. But we have other things as well that we can check. If we check the main.tf file, sorry, we have already checked the main.tf. If we check the readme.md file, we'll see that it's just a generic information that lab source repository. Nothing that interesting. Again, again, we have one more sort, and I think we will be getting something interesting. So for the variable.tfr file, we have variable location name, resource group, app service plan name, and web app. Okay, this could be something interesting. Like as I've told you earlier, we only need the web app name to work with it, right? We don't need more pieces of information. Once we have a web app name, we will add a context to it. Now the context, let me just show you. So once we have a web app name, we can put dot Azure websites.net. Not an issue. Let it load. So one thing that I would like to say is that these applications are hosted in a container. So it might take certain amount of time to actually, load this. So let's hope for it to load. Okay, it's there. Now, okay, we were hoping for something interesting out there, website containing some sensitive information, but turns out it's a stock website with nothing hosted on it as of now. But one piece of information we are getting that it's a Python environment, and that's it, right? So what do we do now? We found a website, but there's nothing on it. There are other operations that we can try, like GitHub is like infamous for storing secrets, variables, and other pieces of information. Let's check if we have secrets. Just just a second. So let's check. Do we have the permission to do it? Okay, no. So it's saying that fail to get secret 403 unauthorized. It's not accessible by the integration. Now this integration is talking about the GitHub application that was access token that we actually found, right? Another thing that we can try is the variable. Okay, out of luck now. Now we're stuck. We found a web application. We try to see like if there is some kind of secret store that we can use to pivot back to Azure, but like we don't have anything as of now. But if you remember, we talked about one more thing while we were talking about web apps, which was the buddy site, right? The Kudu application. To use the Kudu application, all we need to do is put an HCM in the middle and enter. Well, it's asking for, enter login now. And we don't have that. We try to find options like, we try to look into the secrets or variables uh, that might have any kind of thing that we might use, but no, it could not. Another thing is that I think anybody working with Git or GitHub should check is GitHub logs. Why? Because most of the time, or there are many incidents where people make mistake and push something that should not be there, right? So checking Git logs help us to find those things. Even if those things are deleted, we can still see them. But in our case, as you can see, nothing is deleted, just three files that we already saw. So there goes our another sort, right? Back to square one. Now, but we do have one more piece of information, right? Which is to check if basic authentication is enabled or not. So we'll check that now. We'll add the SCM in middle and we'll do basic auth. Great. Well, we have another thing we could use, but it's asking for username and password, and we have none. So we might try to, look for any other options or, pray to God that we get certain information, or we can just recall a piece of information that I was discussing during the theory, which was that there is one more, endpoint that is used to manage the user label deployment credential, which is the publishing user credential, which is the publishing user endpoint. And if we call that particular endpoint, we might get something. It's a success, publishing user.web, and the username. Okay, we have one piece of information, right? We have one piece of information, which is the username. So we need one more thing out there to actually log into Kudu and get access to this all lucrative stuff that I was talking about. But how do we get it? We talked about this endpoint and we made an guess that we might be able to get it. Now, while doing this, keep one thing in mind that these are not the configuration related to this tenant, right? We are working in a tenant where we have nothing. We are a guest. We just got invited out here. We are viewing all this configuration that this user might have made in his home tenant. We have fetched the user and we are just abusing those global ARM APIs for our use, right? So since we were able to get the username, but the publishing password is null, if it had the password, we would use it and it would make our life easier, but that was not possible. So we'll take another educated guess, which is if we are not able to get the password, we will reset it, right? Force our way into it. So let's keep a very strong password, right? Very strong password, and we will patch it. The piece of information that we got, we will patch it. Let's run this. Okay, what it is saying? So it's saying that the specified password does not meet the minimum requirement, right? We are using basic authentication, but still we are not meeting the password requirement. It's funny, right? Using basic authentication and then getting popped up for something like this. Well, we have an option for that. We might create, like, we want to create a strong password now, right? So we'll create a very random password, which is random 123, and we'll try our luck again. Let's see. Okay, it's a success. It's a great news for us. So what we effectively did, we found a username and then we reset the password, right? That's the two things that we have done. And that's the two things that we require to access the Kudu site, right? So let's test it now. We did it, we got the success. But one thing that I pointed out that we all need to remember is that even with the a username and password of user deployment credential, if a user does not have the access, the minimum website contributor role, we won't be able to use it. Now we are hoping that it's there, right? So let's get this back, and we need to get the username again. Just a second, we will get it. We will copy the username, we'll paste it here. We will, get the strongest password that we can make, copy it, and then paste it. Sign in. Let's see. Let's see if all the things that we did actually worked or not, right? Everything depends on this now. This is our last shot to, get our hold onto one of the resources present within the another tenant, right? So let it load. It might take a little time since this is also inside a container and it might take time to wake up. Let it run. Let it run. Okay. It's taking a bit time. Let's wait for it. Give me a second. It's taking much more time than usual. Let me open another tab and try logging in from here. Okay, it worked. Both of them worked. So I'll close one and see the screenshot that I showed you. It's finally live, right? So whatever information that I was showing, I can say that now, yes, it's true. And this is the interface that we have for a Linux-based app service plan. For Windows, as I mentioned, it would be different. So let's check out the different things that we have, right? We have environment informations, app settings, connection strings, nothing interesting out there. Okay, we have the environment variable. This could give us something interesting, right? We'll get back to it. Now let's explore a few other things. In the log, we could have a log stream and the container logs itself, the SSS option that I was talking about, the file manager. Let's see if we have something out there. Services, logs, just a random number. Let's take the sites folder. Well, repository, nothing. Nothing in the file system out there. Okay, so we don't have anything out there right now. But the one thing that I mentioned previously was that we were talking about how the Git, like how a web app is not an individual thing, right? There might be uh, there might be a lot more integration going behind the scenes, right? So it might be integrating with other resources and all. So one thing that we can look into is the environment variable and try to find if it has any managed identity. If we type the identity here, okay, we are not getting anything. So does that mean that it does not have identity, managed identity? Well, no. There are other options that we can check to verify it. For that, let's go to the application itself, right? There's a difference how this environment variable, like this environment and container instance work for Windows based web applications and Linux based applications. We won't be going into too deep into it, but to when working with Linux based systems, the Linux based web app, you need to see the web application container to actually find those environment variables, right? So now we are inside the container itself. If we check who am I, I'm a root user. Great. Let's check the environment variable for this, right? Is there anything interesting out there? Well, there is. Can you see this? The identity header and the identity endpoint. Let me mark it for you. See, these two pieces of information will help us understand or confirms that yes, this endpoint, like this particular web application, has a managed identity. Well, so what? So what we have a managed identity? What can we do with it? Well, one educated guess could be since it has a managed identity, and well, it might have access to resources, or it might be used to, it might have some intra permissions and other possibilities as well. So for that, what we can do, we can get the access token of this particular identity, try to log in and see what all can we do with it, right? So we will get the access token. I will paste it, hoping that we get the access token. Great, we got it. So what I'll do is I will copy this, go back to our PowerShell terminal, clear it. Sorry for that. And store it in a variable, right? Store it. But before that, let's check one more thing. One more thing. Let's get a confirmation, right? We'll go to jw.ms, we'll scroll down. Now we'll see that the issuer is some other tenant. Previously, it was 3A something. Now it's 5A. So essentially, what we have done is we were working with an account that did belong to some other tenant, but in our tenant that we had access to had nothing. We enumerated certain, we went to GitHub and we got something out there, like we got the web app. And using the web app, now we have a chance to finally enter into the Azure environment, right? So let me close this. One more piece of information that we need is the client ID. Let me copy the client ID, copy it, and I'll store this in a variable as well. Paste it. Okay, great. So we'll try to connect using this access token of managed identity and the client ID, hoping that this would work. Great, great, it worked. And now we have a subscription as well, which is a good news for us. It's a great news for us because previously we were going blind, right? We were talking about a particular, two endpoints that are global in nature, which we have not heard about, but we still used it. Now we have something concrete. So let's check. Let's check what all role assignment do we have. Let's wait for it to load. There might be a lot of role assignments. Good for us. Might take a little time, but that is not an issue. A second. Okay, it's taking a lot of time, but let's not waste our time. So what we'll do is we'll create a session and check other things. Not a problem for us. So we will get the token out here again. From here, copy it again, paste it. See, still going on. We'll get the client ID. We'll connect again. Right. In this one, let's check the resources first. Since the role assignment does not want to help us today, we'll try the resources part. Let's wait for it to load. Okay, so we have something now, right? We have one, two, three resources. First one is the web application. And if you look closely, this is the same web application that we have been using that give us a chance to enter into this Azure environment, right? Second one is a key vault, good news. And last one is a logic app. Okay, so let's start with the keyword itself. Let's try and see if we can get any piece of information out of it. Get is it key vault secret dash vault name, and we copy this. Let's run it. Nope. What about the role assignment? Okay, it's still going on. Let it run again. We'll see. We'll see what goes on there, right? Key vault secrets. Do we have any keys? Well, no luck out there. Let's check one last thing, right? The certificate. Okay, we are not right. No, we are not authorized to do it. Okay, it's loaded. Good news. Let's expand it a little and let's check this. Like we'll keep the context of the resources out there. Let's go through it. So since it is a managed identity, we are not giving any display name or signing names for it. There is a reader role for this particular web application, and we are also able to view it. So that's cool. There's a website contributor role. For this particular website, we can take an educated guess that since I have been repeating this word again and again, that a website contributor role is needed to make this configuration, this might be the original permission that the user had whom we are exploiting, right? The guest user that we are exploiting, this permission might be belonging to that user, right? Another website contributor, more website contributors, well, a lot of things, right? And there is a keyword secret user, right? But as we tried to get the keyword secret, we were not able to do it. So, but this is assigned to a object type service principal. Like other of these, like these things were assigned to users, but this particular was for service principal. But uh, something, it was our bad luck or whatever you can say. We were not able to get it. Now there is another piece of thing out there as well, which is the logic app, right? Get is it logic app. Let's see what we have there. Okay, so we have a logic app in a particular location. We have the access endpoint, right? Nothing too, important for us to look into. But what we can try is we can try and see if we can get we can check the workflow of this logic app. That would be very interesting, to understand the actual, how when I was explaining, the components of it, the trigger, the response, any connectors, right? So let's get the subscription ID, the resource group, the workflow name, and we will call the workflow endpoint to capture the response of this particular logic app, right? The particular logic app that we got here, the workflow name. Let's check. Okay, a lot of details is out there. Let's scroll up. Let's check each and everything so that we don't miss out on anything at all. So this is the trigger. The trigger name is when an HTTP request is received. Great. And the input type is get. So from this, we can understand that the only possibility of, of triggering this logic app is when we make an HTTP request with a get method. That is clear. Second, when action is successful, what it does, it responds a body that contains get secret value. Now, what is get secret? It's saying that get secret runs after what? The exact URL. See, this is the exact key vault that we find. Actually, let's see that again. Get is it key vault. So KV lab LATC 7481, right? will see 7481. So this would get a secret from this key vault whose name is secret and holds like the container is secret and there's a flag. This is the actual value that we are looking for. And it is also making a GET call and it is authenticating using manage identity. So remember that we saw the role assignment that a service principal had keyword secret user. Yep. So this is the managed identity of the logic app. It is able to get this flag because it has keyword secret user. That's it. That is the exact actions that is being performed. Okay, let's go below and check few other information. We have a parameter which is empty. For access control, it's saying that we have open authentication policy. So OAuth policy, and it is for a web app managed identity. It's a web app managed identity policy, and there are certain claims to it. The claim is the issuer must be from this. So whenever you are seeing this, just remember that this is the tenant ID. The issuer must be from this tenant ID. Okay, that's the first thing that we have, and it's a good news because this is a tenant that we have logged into. Second is the audience. The audience must be for management.azure.com. If we check the decoded code that we have, the audience management.azure.com, the issuer sts.net, and the same thing. Okay, 2 out of 2. The last thing it's saying that the subject should have a value of this particular GUID. Okay, what does that mean? Does that make any sense? Well, not right now. I don't know. Like, I'm lost for now. Let's keep looking. Another thing is this SaaS authentication policy is disabled. So if the SaaS authentication policy is disabled, there is no SaaS token on it. So the only way to trigger this logic app, if we are able to satisfy all these claims, right? If we satisfy all these claims, we will be able to get it, right? So we looked into the 3 resources that we had, and we saw that we have a web app, logic app, and a key vault. And on top of that, we enumerated all this, but we have landed to a position where we can get a flag if we are able to call this logic app. But there are certain claims to it which we are not able to satisfy. But remember one thing, I explained earlier that a web app is not an isolated entity. There might be multiple things going on, right? There might be integration, like as you see that with the app service, with the web app, we also have a key vault and the logic app. This all might be embedded together. So we can take an educated guess that there might be something interesting with the web app itself, right? So let's just check it out again. Let's just see if we get any piece of information that we can work with. Okay. Web app name, few pieces of information, nothing interesting. Site configs, and what the identity part. We do know that this web app has managed identity because that's what we are using. Now, if we take a guess, like an educated guess, that the GUID that we saw that might be related to the web app itself. It's a good guess, right? We have a web application, we have a logic app. It could be used to do something behind the scenes, this enterprise environment and all of those logics. So let's put an end to our suspicion and let's just check it. Check the identity. So it is a system assigned identity, and the principal ID is 077 and other things out there. We might have seen this somewhere. Wow. So this is the exact GUID that we need to make this call. Let's check this out in the JWT token that we have. We are hoping where we are very hopeful. Check the subject. So previously, when we were going through these claims, this subject did not make much sense to us, right? We were trying to find out what tenant we belong to and what other information that we had. Did the managed identity have any kind of permissions to it, which was not there? But now the subject is matching. So what does that tell us? That tell us that this particular managed identity can trigger this logic app. Remember the three things. We have a trigger, we have a action, and finally a connector. The connector here is related to the key vault, and the trigger is done using the our managed identity. And finally, the output that we'll be getting is the logic app. Sorry, the flag once the logic app is called. Okay, so we need few pieces of information out there to actually make this happen. We need to construct the callback URL for it. Obviously, since the SaaS authentication is disabled, we won't be getting the SaaS token. But even without that, we can work with it. Since that is disabled, we can use the or. Since that is disabled, we have another authentication method that is OAuth. Let's try and use it. We have already seen it, but let's review it again. This is the access endpoint that we viewed when we were looking into the the entire workflow, right? Second, we need the trigger name. Let's get the trigger name. So is that logic app trigger name, which is the workflow name, resource group dot name. Let's check what it is. Trigger name. We saw that earlier as well when an STP trigger, when an STP request is received. Great. The last thing is we will construct this logic app URL. How? If you check the Microsoft documentation, it states that for the logic app URL to work, we can combine it or we can construct it using access endpoint slash trigger slash the trigger name and path, invoke, and the API version, right? We'll do it. So let's check the logic app URL. Great. We have the logic app URL. Now, what do we do with it? Well, it's a logic app, right? Once we get the logic app trigger URL, we should be able to trigger it. Let's try to do it. Let's call it. Okay, we are not that lucky, right? So what it is saying that the direct API authorization required, the authorization schema is required. Please add authentication schema and try again. Basically, it's saying us back off, right? Don't try to trigger this URL without any authentication context. So what can we do? Well, we saw that the managed identity is the thing that will be able to trigger it. We got its access token, and we have it stored in a variable known as tokens. So we'll check that again. So this is the exact token that we are talking about. So what next? Well, we can create a header. Since when we were trying to call that logic URL, like logic app URL without any authentication context, it was asking us to back off. Now we are going it with some gunpowder, and that gunpowder is this token, right? So let's make a call now, right? We have the header. We will make an REST API call to the logic app URL that we have constructed out here, right? And we will press enter. And we are hoping that we get some response out there, something. So if we'll copy it, let's clear the ground, right? Let's clear the ground for us and get a little down. Let's check what response we got. Okay, great. See, we saw the exact workflow that the logic app was going to do. We found the trigger that would make it happen. We found the managed identity that would be able to trigger it. And understanding all those context, we constructed the logic app URL. And finally, we have the flag. Well, one more thing is remaining out there, which is to verify this flag, right? You can go to the flag section and verify it. I'm hoping that it says that this is the flag. Great. See, I got the badge. And on Monday, when we'll be releasing this lab, you guys can try it out as well, and you'll be getting the same badge, right? So that summarizes our demo. And so that is how we got from, like, we as a guest user, we started as a guest user, and ultimately we access another tenant and got a critical piece of information, and that's what we needed, right? So uh, that summarizes our demo part. Now, if you have any questions, like until now, if anyone have any questions, please let us know. And I would like my co-host, it is, to summarize all these findings that we have done till now.
Thank you, Prajwal. A very dense, information loaded theory part, followed by a superb demo because the lab is very, very big. I get it. So let me just I would just like to recap everything that he has explained, Prajwal has explained. Is my screen visible?
Yes.
Okay. Yeah. So let's begin the recap of everything that has been done till now. So basically, we had a user, and that user in its home tenant was having an access to a web application. So naturally, in the home tenant, the user can access the two endpoints, publishing user and the source control. In our scenario, we fish the user to get his credentials after we invited the user into our attacker tenant. With these two pieces of information, we set MFA into our own tenant on behalf of the attacker, on behalf of the user, because we already have fished the user, so we have its credentials. And with these 2 points, we basically call the source control endpoint. When we do that, we get access to GitHub Access Token, GHS, which we all saw during demonstration as well as the theory part. In GitHub, we, after authenticating to it, we basically got the Terraform file where we get the information about the web application. We basically check whether the application is having basic auth enabled or not. Because it was enabled, so the next best thing was to call the publishing user endpoint, get the username, and then get the reset the publishing user password. Because basic auth by default requires username and password. With the ability, by abusing the publish user endpoint, we can reset the password. Now, mind you, if suppose the home tenant has more than one web application, when we reset the password using the publishing user endpoint, it will reset the password across all web applications. So now we have the username and password, and we can authenticate to the Kudu service, which is the buddy portal. From the Kudu environment variables, we got the access token of the managed identity, and we enumerated everything that we have access as the managed identity in the home tenant. During enumeration, we found that there is a logic app. We further enumerated the perfect trigger URL. Based on the commands that was demonstrated by Prajwal, we basically constructed with the proper subject and the audience. When we triggered the logic app, we got the flag. I would like to point out something here to explain the entire bug once again. Mind you, when we fish the user still authenticates to the home tenant, but the access token will be given by our guest tenant. And if we get the access token from our guest tenant and we are still able to call the publishing user endpoint or the source control endpoint, it means the tenant boundary is not isolated when it comes to global ARM APIs. And that is the main bug. I hope everybody was able to understand it. Is there any query till here? Because before moving to the mitigation part, I just want assurance from my audience that they have no more queries because we will be ending the webinar soon. So if there's any query, the attack bar diagram is in front of you. Feel free to ask. Someone is typing. Great. Thank you. So let's move ahead. So if this happens in a real scenario, it would mean that the production environment is burning. But for us as the attackers, we can say we got the flag. Or in real life, it would be that we got the access to a key vault if we replicate the situation, which is a very sensitive piece of information because we can unlock more things using that secret. Now, about mitigations. See, uh, when the GitHub access token was demonstrated during the theory as well as the practical, and when I also explained the kill chain, remember that it was a classic PAT, which is a classic personal access token. But if we try to use deployment center with source as GitHub in Azure portal, we don't get an option to use find int PAT. This option can be made available to the defenders or the IT administrators using AZCLI. Post the session, I will submit the AZCLI command so that if somebody in the IT administration wishes that instead of the classic pad, which you can say has a broader permission base, can use find and personal access token, which can be scoped at a particular repository. If I have to explain it, previously the pat will look like that when we authenticate using the portal. But if we use the fine grained access token, then we get the option to limit the access itself, which in my opinion is much better. Second mitigation, we can configure OIDC for GitHub Actions. Now, what do I mean by that? Listen to me very, very carefully. What happens in case if we want to avoid the PAT and everything? In Azure Entra ID, we can create an app registration and create corresponding service principal of it. Then, using federated identity trust, we can make that service principal authenticate by providing by configuring it or integrating it with the GitHub Actions. It means whenever GitHub Actions in the login flow will come to Entra ID with the tenant ID and the service principal client ID. Because of the mutual trust, the Entra ID will issue a small live access token to the GitHub action. And using that, access token which has a short shelf life, the deployment can be done. So no need to manually maintain any secrets or rotate any secrets. Based on mutual trust, a short-lived access token would be provided to GitHub, and the deployment will happen through the CI/CD pipeline. Now it's 2026, so I don't have to like explain it, but I request all the developers to not use basic authentication. Just disable it. It's a very self-explanatory line, but I would still like to emphasize on it. Basic authentication does not support MFA. So it by default carries an inherent risk of being compromised, just like we demonstrated in the lab. Most importantly, whenever we are collaborating with external vendors or partners, instead, like in the home tenant, the IT administrator can manage the external collaboration. It means block every invite except our trusted partner. And also, it can be for per user. I will give you an example. If I have blocked, all the external tenants except one, which is the partner or the sister organization, and in that the work is purely technical, or let's just say the work is purely on CXO level, there is no need for any finance guy to be invited into that tenant. Then with the per user setting or the per group setting, we can, you can say whitelist only those users from our home tenant which has business in the partner tenant. So such tight control will help to minimize the attack surface. So thank you everyone for your attention. This is a very dense explanation that we have given. So we do understand that there might be a lot of questions. I will be handing over the control to Prajwal once again so that if there are any queries, he can answer them. Over to you, Prajwal.
Yeah, thank you, Hitesh. Now we are open for any questions you have. So please go on. Anyone, any questions out there? Anything related to the lab or the theory or the overall webinar itself?
Whatever queries the audience has, they can put it on the Discord channel. Someone is
Okay.
typing.
Yeah. No queries. Thank you very much. Anyone else?
Thank you.
Yep,
I,
yep, you will get the slides. This will be available on Monday. So you will get the lab and uh, in this in the separate tab, you will get the the slides as well. It will be there. Thank you for joining.
thank you. Someone is typing.
Thank you very much.
Even after the webinar, if someone has queries while rewatching it, feel free to tag us in the Red Labs Discord channel and we will try our best to answer your queries.
Yeah. While you're going through the recordings or while you're going through the labs, whatever queries you have, we'll answer it for you.
Thank you.
And I do like to mention that you guys can check the our Red Team Labs portal. A lot of labs are available there, and the individual components that I talked about, like for example, Logic App, we have an entire range of lab for it, which you guys can explore as well.
Red Labs is completely free. Whenever you feel like you want to learn about Entra ID and Azure Red Teaming, you just need a Gmail or a Google account. You can log in into our portal and get access to all the labs. We will wait for 1 more minute if anyone from audience would like to ask any questions. We have a webinar on next Friday, and it will be from Nikhil Mittal. So don't miss it.
Someone
As
is
there are
typing.
no more queries.
Yeah, someone is typing.
Yeah, someone is typing.
Okay, great, great to hear.
We hope you like our lab. We have worked very hard so that we provide some quality labs to all our subscribers on the Red Labs
Yeah,
platform.
there have been a lot of changes to just get these labs up and running.
As there are no more queries, uh, Prajwal and I will take a goodbye with everyone and we will end today's session. Thank you, everyone. Bye.
Thank you all. Bye.